resources and your costs. It's quite a bit of terms to start out this chapter, so we'll try to work through them methodically, and then I'm going to have some examples of the types of forms that I would like to see you develop for your respective projects in this class. So let's start with an overview of resource scheduling. Well, resources and priorities. Project network times are not scheduled until resources have been assigned. Let's do a little edit like we do here with the slides every now and then. Are not scheduled until resources have been assigned. Now this kind of goes back to the project definition, where you have to break everything down into smaller pieces, and the smaller pieces you have, the easier it is to be able to allocate your resources to them. There are always more project proposals than there are available resources. So think about in this corporate environment, you're on a team of 5, let's say, and there's 5 other teams, and they're all competing for enough resources to run 2 projects. And once those 2 projects are chosen, the members of the teams that are on the projects that were not chosen are going to get rolled into the ones that were, and the ones that are on the project that did get chosen are going to be team leads. The project priority team will add a new project only if the resources are available. So they're only going to fund your project if you're have the resources available and you have proven to have a worthwhile project. Cost estimates are not a budget until they have been time phased. We're going to talk a lot about time here. Keep in mind that while most people think in terms of scheduling resources, they think about money. Actually, the one thing that's more scarce than money is time. You can make $1 million, lose $1 million, and make another $1 million in business. You'll never get the next 5 minutes back. Once resource assignments have been finalized, you're able to develop a baseline budget schedule for the project. So you can budget your time, your money, and your allocation of input resources. Now, resource smoothing involves attempting to even out the varying demands on resources by delaying non-critical activities using slack to lower peak resource demand and thus increase the resource utilization when resources are adequate over the life of the project. So think about you're working on a paper by yourself. There are certain parts that you have to outline, and then there's certain things that you have to write first, and then you bring things together. You never write the opening until you've written the closing, and never write the closing until you've written the meat of the paper. So in your time, if you're writing a term paper, you have to do a little bit of resource smoothing. Resource constrained scheduling occurs when resources are not adequate to meet peak demands. The late start of some activities must be delayed, and the duration of the project must be increased. Think about every building project you've ever been a part of. Or ever seen being a part of. It never really stays on schedule, but, well, there is a schedule, and at least you know you're headed towards being off schedule, so you can use lag times to underpromise and overdeliver in the long run. Now, there are different types of project constraints. There are technical or logical constraints, which are related to network sequencing, in which the project activities must occur. So think about you building a house, right? You must pour the foundation before you build the walls. You must build the walls before you can build the ceiling. You must build the ceiling before you can build the roof, so on and so forth. Resource constraints. This occurs when there's an absence or a shortage or a unique interrelationship or interaction characteristics of resources that require particular sequencing or project activities. Man, I feel like tonight, I'm recording this in the evening, I'm going to keep coming back to the construction and building situation. So we're in a post-COVID environment, and we had a lot of supply chain interruptions. And windows are really hard to come by. It's like a 9-week wait for windows nowadays. So when you're building a house, you can't really, start hanging the fixtures until you've put in the windows, because you don't really want the wind and rain blowing in, messing up your fixtures. So there are things that are constrained by a shortage in inputs. Similar with the car industry in post-COVID, there was a several months shutdown, which cut out the amount of microchips that could be manufactured, which then meant cars can't leave the factory because we're very dependent upon microchips in cars now. So note that resource dependency takes priority over technological dependency, but it does not violate the technological dependency. So while there are certain things you have to build a car, or build a house, or conduct a project, you do have some sequencing here, and that one thing has to be available before you can move over into the next step. And the microchips was a good example for a technological dependency. Most of our cars run now on microchips. Types of resource constraints. You could have not the right people to do the job, or that it's a really competitive job market out there right now, and you can't afford them. You could have not the right materials or not the right equipment. I think we've seen all that in a post-COVID environment. So classification of a scheduling problem. Time-constrained project. You guys are doing a time-constrained project. There's a deadline here. It must be completed by an imposed date. The time or project duration is fixed. In this course, you had 16 weeks, then you had 10, and now you have like 8. It starts to tick down. Tick, 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 tick. And resources are flexible. If required, resources can be added to ensure the project is completed by a specific date. You can give it more time. People tend to procrastinate and put in a little more time closer to deadlines. Resource-constrained projects assume that level of resources available cannot be exceeded. So the resources, the money that you have on hand, the inputs you have on hand is all you have. Resources are fixed and time is flexible in terms of how and when you complete, as long as it's before the deadline. If the resources are inadequate, it can be acceptable to delay the project. You can consult a project priority matrix, which we talked about in a previous lecture, in a previous chapter, to determine if the project is on time or if it is resource constrained. You can look at a Gantt or a PERT and be able to quickly ascertain if you're on schedule. So we're talking about resource allocation methods here in section 4. There's some limiting assumptions, which means splitting activities will not be allowed. Splitting refers to interrupting work on one task and assigning the resources to work on a different task for a period of time and then reassigning them to the work of the original task. Level of resources used for an activity cannot be changed. I think building, because you're building things, whether or not it's a good or a service, but the building industry, if you have any knowledge of how a house is built, sometimes they have to pull some laborers off of one part of the house to make sure the roof trusses go up straight, and then they put those laborers right back into preparing the floors. So sometimes you have to split your resources and pull people over. That's called being a good project manager, that can allow you to stay on task and under budget and on time. Now, we talked about last chapter all about risk. Well, risk assumptions are activities with the most slack pose the least risk. You've got plenty of time to do this. So you have a lot of slack, so there's least risk. Reduction of flexibility does not increase risk. The nature of an activity, easy or complex, does not increase risk. What happens is you have more risk when you have, less margin for error. So let's say you have 3 days to do something that should take 4 days. You have the margin of error is really, really thin, so there's more risk. So again, continuing with risk assumptions here, must be imposed, but it must be done by an imposed date. As you get closer to that date, the risk goes up. You got to focus on your resource utilization and require resource smoothing techniques that balance demand for a resource. So again, you've got to be a good manager of your labor, of your money, of your inputs, and of your time. Leveling or smoothing techniques delay non-critical activities by using positive slack to reduce peak demand and fill in the valleys of the resources without delaying the entire project. So if you think about smoothing your time as a college student, I know when I was your age, I enjoyed playing video games, but I also realized when there was something to be done, I realized that I can enjoy playing video games after the project is done, so that maybe I have to shot across some of y'all's bows there. So goals of smoothing resource demand: reduce the peak of demand for the resource, reducing the number of resources over the life of the project, and minimizing the fluctuation in resource demand. One of the biggest ways that you can smooth your resources for these projects is to break them down, to define them clearly, to narrow your scope, to zero in, which allows you to break things down very, very simply, and then allocate your resources to smaller tasks. And then you can smooth those tasks. Like if we're working on editing a paper and we didn't have a whole section written, we need to move our emphasis over to writing the paper, and then everyone can edit at the end. You want to minimize your fluctuation in resource demand. Basically, you'd like to stay on plan. Downside of smoothing resource demand: there's loss of flexibility that occurs when reducing slack. If you take people off of tasks that burns a day, say they were hoping to be able to have some slack on, it creates more critical activities and or near critical activities because of the slack reduction. It takes away your margin for error. The book goes into several examples now, and I'm going to show you a couple graphics here. We have a Gantt chart coming up. And this one in particular, I'll let you read about this. It's about a botanical garden, but hey, that's great and all. But I just wanted to show you what I'm kind of looking for here in terms of a Gantt. You have the design phase, overlap with a bit of a a layout rather in a scaffolding. Scaffolding, is that preparing the ground for it? I believe that's what that means. And then you're going to start putting in some walkways. Well, also while you're putting in walkways, people are installing some irrigation and then fence and walls. And then once all those things are done, we've got people working on lighting, and then we all come back together. We merge back here at planting trees and flowers and grass and everything for the botanical garden. This then moves into, so this is your overall kind of Gantt timeline. And then this moves into, say, one resource, which is, let's say, backhoe tractors. And you could have 1, 2, 3, 4. And then we're looking at the different phases. Early on, you only need, let's say, 2 to get the ground prepared and to prepare the layout. But then we get in this this multiple activity at the same time. Where we kind of divide and conquer, and we're going to need 4 backhoes to be able to do the walkways, the irrigation, the fence and walls all at the same time. But then we go to lighting. Don't need but maybe 1 backhoe tractor. And then we go to planting, and we're going to need 3 because we're planting all over the place in this botanical garden. So this would be ideal. Like, hey, we're going to have peak tractors here, peak here, low there. Well, let's say you're renting this tractor, and do you want to go to the rental store and just rent 2, take them all back, rent 4 for this. For this 6-day period, you're going to rent 4. Then you're going to take them back and then rent 1. And then for the last 8 days, you're going to rent 3. Seems a little clunky, right? If you smooth that, if you average it out, let's have 2 here on hand. Then let's split the difference here and have these teams here split 2. They can't all. So over here, they could have 4 backhoes, but you can't tell me they're all run at the same time. Whereas you could have 1 and they were all run at the same time, and then to finish up strong. So if you don't have 4 here, it may take you a little bit longer for these steps right here. But if you have, 2 or 3 of them at the same time, while this may get extended a little bit over here, you don't have to do this back and forth where you're renting them, not renting them, okay? Or you're using them, not using them. Let's say you do own 4 backhoes, but why are you just using 1 right here when you could just keep them for this amount of time and smooth this resource over and just have them available, which could cause you to have to adjust your Gantt, okay? Kind of disappointed I don't have a project at the moment when I'm recording this that involves tractors. Okay. Resource-constrained projects. Resources are limited in quantity and availability. We've talked about scarcity there. Activities are scheduled using heuristics, which are, as a funny word for rules of thumb, by following the priority rules. Let's have minimum slack, the smallest least duration that you're using each resource, and the lowest activity identification number. Okay, this kind of goes back to the arrow and node that we talked about in a previous chapter, two chapters ago, where we're doing that early start, early finish, late start, late finish. So you try to tighten that down. If you tighten that down, you can get more efficient. The parallel method is used to apply heuristics. Remember, this is a parallel method where you have parallel activities going on at the same time. The parallel method is like an iterative process that starts from beginning of the project time, and when the resources needed exceed the resources available, when the resources needed rather exceeded the resources available, it retains activities by first by priority rule. So what of these activities need to get completed first? Okay. If we go down to backhoes here, I think, if you had limited smoothing resources here, and that actually would cut costs here. Imagine like I said, if you were renting these things and there were delivery fees for every time, but this much variability, you're gonna get eaten up with delivery fees. So once we've prepared the ground, scarified it, and gotten our layout, I definitely think you need walkways before you need fences and walls. Okay. You may do irrigation before you do walkways. So let's say we go irrigation, walkways, fences, and walls in order of priority. Okay, now you know where to send your limited resources first. Then you allow it to move to this next phase where you will get it done a lot quicker Okay, you're going to get lighting done really quickly if you get this many tractors down there. Okay, you see how that starts to come back around? So you need to know what resources that you need, and then how to allocate them, and then how to allocate them much more efficiently through using the parallel method. Okay, lowest activity identification number. This is going to look somewhat familiar here. You've broken down everything that you have to do. Okay, so here's the, let's say, design and layout. Or are we using the same example here? Sometimes I switch up. Here are the three parallel activities. Here are some parallel activities, and then we come back together. Early start, early finish, late start, late finish, or slack, and how many days it's going to take, and then the duration. Okay. Here's your Gantt chart. Again, you can do this in Microsoft Excel. You just need to be able to break out things. These are just examples of things you could use. That's an arrow and node into a Gantt. Again, arrow and node, or from a Gantt back to an arrow and node, and you can say, hey, if our resources are constrained, here's our schedule. Okay, here's our final schedule. So you're going to have different iterations throughout this as you do your milestones. EMR project, the development of handheld electronic medical reference guides to be used by emergency medical technicians and paramedics. Electronic medical records is what this is called, EMR. This is a funny story. In a previous life, I was in medical sales, and anytime I was going to a medical office that said, hey, please be patient with us. We're training on new EMR today. It's a very frustrating day for them. I knew immediately to turn around and leave because they're not going to be in a good mood. Maybe send them some donuts later. So, in the reading, this is an illustration of a computer demonstration of resource-constrained scheduling. EMRs are actually really good to have because the electronic medical records, you can show up in an ER in Kansas, and let's say you're from Greenville, South Carolina. If you show up in an ER in Kansas unconscious, they figure out who you are. They can pull up your electronic medical records. That's kind of the big push there. That could save your life. So read a little bit more about the EMR in this week's reading in Chapter 8. Resource problem, only 8 design engineers can be assigned to the project due to a shortage of design engineers. We talked about, one of your resources are your people and commitments to other projects. So you can only have 8 engineers that are free to work on this EMR project, and the peak demand is 26 design engineers. Man, I tell you what, this is almost like higher ed. Hey, we want you to do 80 classes with 12 professors. That's kind of tough to pull off. So you got to pull in some adjuncts and do some different things and allocate your resources. And sometimes you have to smooth and pay people overtime and that type of stuff. This resource problem, while we're talking about here in this EMR project, and we're talking about engineers, it's everywhere. It's literally everywhere you've ever been. If you work in food, if you work in the food industry, if you're a waiter or a cook or a busboy, you can tell right now you don't have enough resources, and you have to figure out a way to smooth it to get through the peak hours of a restaurant. So, I mean, it's really applicable to anything. Let's talk about arrow nodes. I don't expect you to understand everything about this EMR project, but I do want you to look at this arrow and node setup. Okay, you're having these big decisions, then you're breaking things down into internal, external, and feature specifications for the EMR. Internal, you want voice recognition, a case for it, a screen for it. External, actually those were internal and external. The case is obviously external. The voice recognition can be an external microphone, as can be an internal part of that as well. And then the case for it that fits in. And then you have these feature specs, just like a database, a microphone, sound card, digital devices, computer I/O, and you bring it all together to review your design. Now, granted, here you haven't even produced anything, but you're going to say it's going to take about 45 days. You're going to start on day 1. You should finish up about day 45. Okay? You should have a plan, an arrow and node that goes from something like this down here to this in your final project. It's going to tell me everything that every piece of your project. That's why it's important to narrow your scope, because if you're too broad, this graphic wouldn't even fit on a piece of paper. You're going to have to narrow your scope, but then break it down to each little piece, and then tell me how these pieces are put together. So if you look at it in terms of a EMR salad here, building a project network for an EMR, here are all my ingredients. Okay, it's going to be a salad. Here are my 3 main ingredients. Here's what they're made of, and then here's how they come together. Okay? That's your project. You're going to have to make sure you're doing that. Again, Once you break it down by day like this, you can make a spreadsheet that looks like this and say, here are all my task steps. Here they are in order, 1 through 13, right? Here's when I'm going to start this one. Here's when it's going to finish. Here's my late start. Here's my late finish. Here's my slack or no slack, okay? You're obviously voice recognition. You're giving yourself 13 days slack to make the case 19 days, the screen 21, so on and so forth. You're building your Gantt chart whether or not you realize it. Go ahead and pull up Microsoft Excel and search Gantt chart. You'll be surprised. If you can do this, you can make this. So if you can put this into an Excel spreadsheet, you can produce one of these, you can screenshot this, and insert it into your project, milestone. So there you go. The EMR project continued. Notice how they broke out everything here again. We have all these things, all these steps broken out, all these tasks. You have design engineers. Let's say you have 8 design engineers. You have broken down each task and how many hours it's going to take. You've got days over here, right? You can make that hours, working hours. You have a total of 3,024 hours. 3,024 hours. And then you can break it down. Again, these are 8 design engineers. You can break it down over, hey, we're going to spend this many hours on these parts on Tuesday. Then Wednesday, we're going to do this. And then Thursday, we're going to do this. Friday, Saturday, Sunday, so on and so forth. To get this project done on time, I need to see a plan of how you're going to break everything down. This isn't a book report class. This is where you dig deep on each individual part. Again, narrow your scope, define each part, tell me what each task is and how long it's going to take you to complete it. Resource loading chart, that's the same thing you saw here. Where are my peak hours? Where are my big numbers here? And you can break it down to say, hey, we are allocated this much. Here's where we're over allocating. You have to pay some overtime to some engineers to get this job done. That is data that you cannot ignore. That is probably a situation where it might, make one of the higher ups say, oof, we got to get you some more engineers, and they can smooth some resources for some other areas and send you some more engineers, and you see more gray than blue here. Okay, blue here means increased cost, and there's a lot of risk right here that you're not getting the job done. Does that make sense? All right, make sure you're doing the reading there. Again, back to your arrow and node. Again, you're going to make something. Here's the 3 main pieces. Of those 3 main pieces, here's what they're made up of. Here's how we're going to bring it back together, and it's going to take, I believe we said, 45 days before? 57 days in this example. So what happened here, we had 45 days. Well, when you have stuff like this, and you can't get it done, you're going to need 12 extra days. So 57 here. Ooh, let's go back. Where is it? Was 45 right here. Bingo. 45. But then you realize that's not realistic because we can't get all this done. There's a lot of risk in here in particular. Sure, some people can work some extra here and make some extra money, but this is a lot that can't be done. How about we adjust our plan? 12 more days, 57 days, we can get it done. Okay? You leveled it out. This is your new Gantt. Okay? Previous Gantt, a lot of stack, right? It's compressed in here. I want to push my hands together. I'm going to push one hand here and one hand here, and it's really compressed. Look how massively compressed that is. Okay? You adjusted it because you understood your demand based on these hours. Okay? You adjusted it, and now look how much more spread out that is. Okay? Number one, you gave yourself some more slack on some of these. You spread it out. Okay? But it went from 45 days to 57, so you're pushing later into February, but you're getting the job done. This looks much more obtainable. This is the level I want you to get in terms of your projects. Well, why? Why are you making me do this? Here's the thing. This is what good project managers do. They level this stuff out. They level out their resources. They make unrealistic Gantt charts like this, okay? Look like this. But what's the trick? Well, this is over a longer period of time, right? This is you waiting until the last minute to do your project. All this stuff is like pushed together, right? This right here is you giving yourself plenty of time and plenty of slack to get the job done. Yes, it goes further out, but the sooner you start, the more your Gantt chart will look like this and not this. You feel me? I hope you feel me. you know what? That's how it is in the real world. Okay, I have to adjust deadlines. I have to give you more time to define your project, that type of thing. That allows your Gantt chart to look more like this. But where does this come from? This isn't just made up. If you find yourself just trying to make a Gantt chart without doing this over here, you don't have your tasks broken down. You don't have your start and your finishes. You don't break it down by how many hours you need. Okay? You got to embrace the horror here. I know that sounds like a lot more work, but you've got to do it. You really do. Okay? The impacts of resource constrained scheduling: it reduces slack, reduces the flexibility. So that's that previous Gantt chart, not the spread out one, but the crunched one. It increases the number of critical and near critical activities. It increases scheduling complexity because resource constraints are added to technical constraints. It may make traditional critical path no longer meaningful. It means you have to deviate from it. It can break the sequence and leave the network with a set of disjointed critical activities. It can absolutely torpedo the whole project. It may cause parallel activities to become more sequential. And it changes activities from critical to non-critical. It gets down to what you really need to do. Now, sometimes you have to split tasks. Splitting tasks is a scheduling technique used to get a better project schedule and or to increase resource utilization. It involves interrupting the work and sending the resources to another activity for a period of time and then having the resource resume work on an original activity. So if we're talking about engineers working on EMRs, if we're talking about carpenters building a house, if we're talking about backhoes being used to build a botanical garden, which we've talked about all in this chapter, it allows those, eventually those resources have to resume the original activity, but they can be pulled off to split tasks. It can be useful if the work involved does not include large startup or shutdown costs, because if it's costing you a lot to move tractors, it's going to be prohibitive to, smooth them. It's considering a major reason why projects fail to meet schedule. Unrealistic expectations, and people didn't define their project and narrow their scope enough. Splitting activity without splitting. Hey, it's just all these activities. Activities split in duration, 3 segments. You got part A, part B, part C. If you have activity A, then you need to shut down and then start up. And then activity B, then you need to shut down and start up. And activity C, it's very choppy here. And if you have shut down or shutdown or startup costs, that makes things pretty expensive. The more times you have this light blue and blue here, if you will. Activity duration split with shutdown and startup. Man, I hate that. I just like getting, honestly, this is every group project paper I've ever done. Hey, we got to hit this milestone. Let's quit for a while. Ooh, we got to get back to it. Wait, what were we doing? Okay, let's hit this milestone. Let's shut it down for a while. Wait, we got to start back up. What are we doing? Part C. Oof. I'm convicted. That's every group project I've ever done. Guess what? That's in school. That's in work. It's much better if you can split them in segments and work continuously. You build efficiencies. Smooth it, baby. All right. Benefits of scheduling resources. It leaves time for considering reasonable alternatives, cost-time trade-offs, changes in priorities. The more time you get out, the more you define, the more time you give yourself to complete this project, the better it'll be. It provides the information needed to prepare time-phase work, package budgets with dates. It gauges the impact of unforeseen events so you can gauge the impact of unforeseen events and assess how much flexibility is needed over certain resources. When you're assigning project work, the reasons why you should not always assign the best people to the most difficult tasks. The best people are resent to the fact that they resent the fact. They don't resent to the fact. They resent the fact that they are always given the toughest assignments. But in this class, in the project management class, you're allowed to assess your teammates. So if you're the best people and you're resenting your teammates, you'll have your say. Less experienced participants, let's say the new person on the team, resents the fact, hey, McGraw-Hill, come on, baby. Resent the fact that they are never given the opportunity to expand their skill and knowledge base. That's exactly what I'm trying to get you to do in this class. Factors to be considered in deciding who should work together. You need to minimize unnecessary tension. Be a good team. Complement each other. And I don't mean, oh, that's a nice shirt. No, compliment with the E. That means your strengths can shore up somebody's weaknesses. You can support one another. Experience, veterans team up with new hires. They kind of meet in the middle. Future needs, have people work together early on so that they can become familiar with one another and build camaraderie. Multi-project resource schedules, problems with the multi-project environment, overlapping schedule slippage. I mean, if you really can't focus on one thing, can you focus on anything? If you're multitasking, are you good at anything? Shared resources can cause a ripple effect. Delays on one project can create delays in another and unnecessary competition for resources. Inefficient resource utilization, different schedules and requirements by multiple projects create peaks and valleys in the overall resource demands. You might have to start stop. Resource bottlenecks, you're all sitting around waiting for a backhoe or waiting for a window to come in, or waiting around for a microchip to come in. If resource bottlenecks, shortages of critical resources required by multiple projects cause delays and schedule extensions. If there's one path that a company's projects always have to go through, and that part of the process is just really slow, it's going to slow down every project. It's going to be this dead period, that start and stop that gets very expensive. Managing your multi-project scheduling. First of all, try not to. Just have dedicated projects, even if it's dedicated project managers, just like we're doing in this class. Create project offices or departments to oversee the scheduling of resources across multiple projects. Use a project priority queuing system, first come, first serve for resources. Treat individual projects as a part of one big project and adapt the scheduling heuristics, again, your rule of thumb, to this mega project. So have things linked together. Break it down. If we were all working towards making the best Michelin tire or the best rubber track or whatever it is, break it down to where you have different groups working on each component of it, that they're kind of dependent upon one another, but they're also motivated to help one another towards one big goal. Utilize project management software to prioritize resource allocation. We'll talk a little bit about this later in the course. Outsource projects to reduce the number of projects managing internally. We're going to talk about that later in the course as well. Hire temporary workers to expedite certain activities that are falling behind on schedule. Bring in some temporary laborers if you're building a house and there's a labor-intensive thing you need to do. Contract project work during peak periods when there are insufficient internal resources to meet the demands of all the project. Using the resource schedule to develop a project cost baseline. Why a time phase budget baseline is needed. See, you thought we were going to talk all about cost here. We'll get to cost here in a second. But the biggest cost is time. So once you allocate your time, then you know how much you got to pay your people and how many hours it's going to take. You can tell me how much you're going to spend on labor. You can tell me how much you're going to spend on equipment. You can look that up. But first of all, you got to break it down into smaller pieces and define each piece and how long it's going to take to do each piece. Then you research on, hey, how much is it going to cost me to hire an electrical engineer or whatever I need to build an EMR, and how many hours they're going to work on it. Then you can tell me how much they cost. So first you got to start with the defining, narrowing the scope, defining, then telling me who you need, how long you need them, and then tell me how much they're going to cost. You can give me a budget. Booyah. To assess how much work has been accomplished for allocated money spent, the project cost baseline. You need the plan value, the PV, plan value, not present value in this case, but plan value. Creating a time-phased budget. So if you do it by time first, you can then make a budget. You can assign each work package to one responsible person or department or deliverable. Compare a plan, schedule, and cost using an integrative system called earned value. And generate cash flow statements and resource usage schedules. So, let me back up here a little bit. No, actually, let me go forward. Direct labor budget roll up. So you got like your modes here, and we're actually your nodes, rather, your arrow nodes, and then we're putting everything into a matrix saying, hey, to make a circuit board, I'm going to need 1,000 hours. Let's say these are hours, or these summarized by deliverable. It doesn't really say, but in the reading you can see this. You're going to need this many resources, 1,000 resources, whether it's hours, minutes, or whatever. And you're going to need 300 for design, 400 for production, 120 to test it, and 180 for the software. You come up with 1,000, okay? You can tell me now how much these people cost. Like, okay, so if you got somebody, an engineer that's going to build a circuit board, I need 1,000 hours from them. Okay, 1,000 times whatever the going rate is for an engineer, research it and cite it, okay? 1,000 times that rate, that hourly rate, you've got a cost. You've got a cost. Then you can break it down. Okay, this whole thing is going to take, 14 days. Okay? You can associate cost with each aspect of this arrow and node, and then with the early finish, late finish, very little lag, you can tell me it's going to take 14 days. You can tell me how much this costs. But yeah, you got to do your homework. Guess what? If you can do these things in the real world, people will pay you, and they will pay you well. Okay? And if you can do these things, if you can come up with stuff like, sorry, I'm scrolling back. This, how many days it's going to take? Gantt chart, spread it out, make it look healthy, and stay away from this type of stuff. Okay? And tell me how many hours? Guess what you can do, folks? You guys have had financial management. You can project a monthly cash flow statement. You can tell me how much time you're going to spend on hardware, operating systems, utilities, system integration. All you've done now is taken those hours and multiply it by the rates per hour, and look at that cash flow statement. Look at that. Look at that. You can look at the costs. You know if you produce X number of, I thought one of these told me how many EMRs are going to produce. If you produce X number of EMRs, X number of events, X number of jobs, X number of whatever it is for your project, you can project your cost now based on hours. To that cost, you add another cost called profit, which should be worked into your price, right? You work profit into, and if you're running a non-profit, the only difference between a for-profit and non-profit is one tax form, by the way. You would call profit excess revenues. You work in your excess revenues if you're a non-profit. You work in your profit if you're a for-profit. And the difference between your revenues and your costs? Profit. So you have to have cash flowing into your organization. You have to know what your cash inflows are and your cash outflows are. And if you can break it down by each aspect of your project, you can tell me month over month how much money you're going to have coming in and out. And that, my friends, is called a cash flow statement. And that is something you need to produce for this project. You don't have to have a cash flow statement for your whole business because we're not doing a business here. We're doing a project. And that was a very 30,000 foot view, brief overview of Chapter 8, scheduling resources and costs. It's all about time. It's all about narrowing that scope, defining each aspect of your project, telling me how long it's going to take, how much you have to pay the people to do it. Then you have your cost, add your profit, and then tell me about the money coming in and out of your organization using your other education like financial management that you've gotten here at North Greenville University. Awesome. See you in the next chapter.